Welcome my dear students. I hope you are all well. अगले दिन हम लोग जो प्रैक्टिस किया था और लेसन किया था वो था रिफ्रैक्शन क्यों होते हैं, व्हाट इज़ द कॉज ऑफ रिफ्रैक्शन, फिजिकल सिग्निफिकेंस ऑफ म्यू दैट इज़ द रिफ्रैक्टिव इंडेक्स एंड सो ऑन. आज जो टॉपिक या चीज़ हम समझने वाले हैं वो है लैटरल शिफ्ट of object due to refraction और practical application of refraction. अब हम लोग देखा है, हम लोग जो नोटिस किया है सब लोग कि अगर किसी भी वाटर फील्ड बकेट या जार में कोई भी चीज़ को अगर बॉटम में रख दी जाए, इफ एनीथिंग इज केप्ट एट द बॉटम ऑफ ए वाटर फिल्ड टैंक, it can be appear to be raised by some amount when looking from up. If this is our eye, then we can see the object in B place in spite of A place. A प्लेस की जगह B प्लेस अर्थात किचु थोड़ा शिफ्ट करते हुए नजर आते हैं. तो ये जो रिफ्लेक्शन का एप्लीकेशन है, दिस इज एन प्रैक्टिकल एप्लीकेशन ऑफ रिफ्लेक्शन ऑफ लाइट. नाउ इन टुडे लेसन वी कैन शो हाउ एन ऑब्जेक्ट इज शिफ्टेड और रेज्ड अपसाइड और अपवर्ड्स व्हेन it is on a denser medium and we look from a rarer medium. So, आज का टॉपिक है एप्लीकेशन ऑफ रिफ्रैक्शन. Application of refraction. Suppose ये एक वाटर फील्ड टैंक है. दिस इज एन वाटर फील्ड टैंक एंड पॉइंट ऑब्जेक्ट इज प्लेस्ड एट ए पॉइंट O and I looking it from the top of the bottom. This is the eye. Now this is optical rarer medium and the object is placed an optical denser medium. Now two rays will be refracted. One is incident normally on the refracting surface. This is M1, M2 is the refracting surface between rarer and denser medium. Now a ray OD is incident normally on the refracting surface and reaches our eyes as OE ray, and the other ray goes obliquely on the refracting surfaces, and if we draw a normal on the refracting surface, as per the law of refraction you know that the refracted ray when reflecting from denser to rarer, the ray is bent away from the normal. That is, this is the angle of incidence I, this is angle of refraction R. I hope you all understand it. Now, this is the normal. Now, if we extend the refractor in backward sides, then it intersect the refracted ray, the normal refracted ray into point E, That is, E is the virtual image of O. E is virtual image of O. Now, we know if two lines are parallel and a point intersect it, and a line intersect it, then the angle produced same side is called similar angle. If this is angle 1 and this is angle 2, then 1 and 2 are similar angle. So, from this picture, N1, N2 and the ray EO, this is I point because E is given already here. As EO is parallel to N1, N2, and this is the line of intersect. So, two similar angle produced, this angle and this angle. This angle will be also R. And again, the angle I and the angle, this angle is also I because of alternate angle. Which is alternate angle? The angle produced as English Z letter. This is two parallel line and this is the line of intercept. Then this angle and this angle is alternate angle. So, these two angles are similar and these two angles are alternate angle. Now, here basic geometry will come to help. What is the basic geometry? Now, from this, if we name this point as ODB and this ray as C, then from triangle ODB, what we get? If this is triangle, this is the angle I, this is perpendicular, BD is perpendicular, DO is base and OB is hypotenuse. Because the angle is theta, which is the theta angle. In case of right angle triangle, always theta is the angle between base and hypotenuse. So, if this is perpendicular, then sine of I, if we know sine I, perpendicular to hypotenuse, that is BD by OB. We can write is BD by OB for a triangle ODB. Again, for triangle, this small triangle DBI, for this triangle DBI, what we can get from this triangle DBI? What we can get? Now, for DBI, we get sine R. That is also this is the perpendicular and this is hypotenuse. That is DB or BD divided by BI. Now, we know that mu equal to, we also know mu equal to, if we take as this is water to air, the relative permittivity, the relative refractive index of air with respect to water, then W mu A as the ray goes from water to air. So we write it as W mu A is equal to sin I by sin R. Snell law, sin I divided by sin of R. Putting the value of sin I and sin R, BD by OB, BD divided by OB divided by BD by BI. So we can finally get BI by OB, as BD BD cancel out, BI by OB. So we have to erase this because the space is not sufficient. So I hope you all understand it. At first we get the large triangle and then small. For large triangle, this is perpendicular, this is hypotenuse. So sin I means perpendicular to hypotenuse, and for this triangle, smaller triangle is also perpendicular to hypotenuse, as W mu equal to sin I by sin R. So what can we get? As we do not need the picture right now, so we can wipe out it. We can get finally that W mu equal to BI by OB. Therefore, A mu W is the reciprocal of W mu A, that is OB by BI, OB by BI. What is OB? OB is the real depth. As you seen from the picture I drawn, just pause it and go backward, previous back play, then you can get that OB is the real depth of the object, and BI is apparent depth. What is apparent depth? The depth which is not actual but appears to be, जिसको देख के लगता है कि वो वहाँ पर है, उसको लगता है apparent depth. That is the virtual image, the position of virtual image from the refractive surface, or the perpendicular distance of virtual image from the refracting surface is called apparent depth, and the position of object from the refracting surface is called real depth. If we take W mu A mu W, we know A mu W equal to mu W divided by mu A. Mu W by mu A, as we know 1 mu 2 is equal to mu 2 divided by mu 1. So if we get A mu W equal to mu W by mu A, then we can get real depth by apparent depth. Now mu W by mu A, if we take mu A equal to 1 and mu W equal to mu only, then what we can get? Mu equal to real depth by apparent depth. Or apparent depth equal to real depth by mu, that is refractive index. This is the formula of shifting an object or shifting the image of an object, shifting the object. Real depth by refractive index is equal to apparent depth. So if we draw the picture again, what we can say, This is point object. The perpendicular rays from O is given as, and the other ray obliquely goes on diverting this on the normals N1 N2. This angle is I, this is R. Obviously, if we draw back it on the backward, it intersect on I. This angle is R and this is I. Then what is the real depth? Real depth is from this is BC. Now what is the real depth? The real depth is now OB by BI. OB is real depth. OB is real depth, and now real depth actually is DO. But as the size of our pupil, of eye is very small, so the ray only will be visible when D and B are very close. So we can write real depth as, in place of OB we can write OD, and in place of OI we can write in place of OB we can write OD, as the distance is very small. So we can also write that A mu W equal to OD by BI. OD by BI is known as DI, because as the 2 points are very close, we assume that B and D points are very close. So in place of OB and BI we write OD and DI. OD, what is OD? OD is the real depth, and what is DI? OI, sorry, what is DI? DI is apparent depth. DI is apparent depth. Therefore, what is shift? Now, what is shift of the image? Shifting of image. Shifting of image is OI. Shifting of image is OI. If we take it small d, then small d equal to, what is shifting? OD minus DI. Now OD is real depth and DI is apparent depth. Apparent depth means real depth divided by refractive index mu. So if we take common OD, we can get 1 minus 1 by mu. And if the thickness of the vessels or beaker or glass slab is T, then OD equal to T. T into 1 minus 1 by mu. The thickness is equal to real depth. So D equal to T into 1 minus 1 by mu is the final formula of lateral shift. This is shifting of image. This is shifting of image. So in this way I can see that the whole formula and also the real application of refraction. Please copy in your book. Then if we take the summary of the today's lesson, what we can get? We get two formula. One is apparent depth equal to real depth by refractive index. When object is placed in denser medium. When object is placed in denser medium. And number 2, shift, lateral shift of image. Which is termed as d equal to t into 1 minus 1 by mu. T is the thickness or depth, real depth. These two formulas very necessary for doing numericals. These two formula is very necessary for doing numericals. I hope you will understand it. Now we go for an example. If a printed page is this is printed page, if this is printed page is pressed by a glass slab with its edge 6 semi wide and refractive index is glass is given mu equal to 1.5. A printed page, this is printed page, a printed page is pressed under a glass slab of edge 6 semi and the refractive index of glass slab as we know is 1.5. Then find the lateral shift. What is lateral shift? That is when we see from the top the page, we do not see the page on this position, we see the page raised above, then how much is the shifting? From this formula we can know lateral shift equal to t into 1 minus 1 by mu. So we can easily go for lateral shift of page d is equal to t into 1 minus 1 by mu. That is, we know the value of t 6 semi into 1 minus 1 by 1.5. If we calculate it, 1.5 minus 1, that is 0.5 divided by 1.5, that is 6 into 1 by 3, that is 2 semi. So we can, the shift is 2 semi, the page is shift as we view from the top is 2 semi. Then what is the position of the page? That is 6 minus 4 is the apparent depth. 6 minus 2 equal to 4 semi is the apparent depth. Therefore the real depth is 6 semi, apparent depth is 4 semi and shift is 2 semi. I hope you all understand this. And also the practical application of refraction is we can see the sun before actual, we see sun before actual sunrise and after actual sunset. If this is earth, this is air, this is air. If an observer is placed at this position as position A and this is horizon, this horizon, actual position of sun is this actual position and apparent position, this is apparent position of sun. Then when rays go from actual position to the observer, A equal to observer standing on Earth's surface, then the ray is going from this to, as we go from rarer to denser, this is rarer and the Earth's atmosphere is denser. So, rarer to denser, the ray will be refracted towards the normal, ray is towards the normal. But our eye, this is observer, our eye cannot trace this path, this bending path. Eye can be traced the straight line path. So, one can see the sun, that is, one can see the sun above the horizon, but the sun is situated below the horizon. So, one can see the sunrise and the shift, the lateral shift here is, the lateral shift here occur 0.5 degree, which is nearly about 2 minutes. So, one can see sunrise before 2 minutes of sunrise, and one can set sunset after 2 minutes of actual sunset. So, one can see sunrise before 2 minutes of actual sunrise and sunsets of sun after 2 minutes of actual sunset. This increase the length of day, equal to 2 plus 2 minutes equal to 4 minutes. So, if the day, actual day is 23 hours 56 minutes, then the total length of the day will be 4 minutes. This increases the length of the day. This is also an application of refraction. I hope you all understand this. Next day we will come with an interesting topic. Goodbye. Thank you.